other router in the internet just does routing the way it would do today. If they weren't deploying it, they would not be concerned with the extra marking that's contained in the packet. But if they were deploying it, in that case, they verify the marking. How do they verify? That's a question, right? Which I'll answer next. They verify the marking and they say, okay, I have verified this marking and I will now put my marking in it. Why do you want to change the marking? You want to change it because so that you only have to know the markings of routers in your neighborhood and you don't have to be concerned with markings of the entire network, of the entire internet. Right? So you verify and the next deploying router verifies the marking, replaces it with its own marking. Every deploying router along the way to the destination continues to do the same thing. However, in order to ensure that the hosts do not receive these marking, the last router removes the marking. Now, there are two questions you should have at the end of this. One is, how is a router in the internet learning the markings of its neighbors? Two, how does a deploying router know that it is the last deploying router to be that this packet would go through? And after this, there will be either legacy routers or no routers along the way, and your packet will straight go to the host. And these markings should be kept secret, because if all the hosts on the internet know the marking, then what's the whole point of the marking? So what do you need to do to have these pieces of information? One, every deploying router needs to know the marking of its neighbors. And two, it needs to know whether when it sends a packet to the destination, there is a deploying router along the way that would strip the marking before it hits the end host. Because if that marking would not be stripped, then you don't want, you just want to verify and not put a new marking. Is that point clear? Because that's kind of crucial to what the approach is. If that's not clear, then we should not go forward. Yes? Huh?
I'm sorry, I said I was just pitching a question.
Okay.
I have a different one that might come up later, though. Here, I'll turn this on. It seems like you have a bulletproof routing network. Like you're protecting against malicious hosts. But what if I have my own custom router and that's malicious?
Okay, very good question. This whole setup is assuming that routers are mostly not malicious. Because and you can argue that, oh, okay, it's a hard problem to solve in general, but you can argue then that the solution then is not useful at all. However, remember that you're not doing anything to the routing, basic routing. So when a router and the internet encounters a packet, it looks at the destination, forwards it. Until you have secured the routing, there's no way to protect the router in general. So in some way, it's like brushing that part of the question under the carpet and saying, okay, we first have to protect the routing, and once that happens, we'll think about how to protect the routing infrastructure. But in general, in this entire setup, we assume that hosts are malicious, could be colluding. However, routers in general are not malicious. And in fact, it turns out that the problem becomes hard enough that if you assume that an entire network of hosts is colluding, then also you can't do a whole lot about it. As long as stray hosts or a small number of colluding hosts are malicious, you can protect the network. But in a very general case, you cannot do that. And here, in this entire approach, our focus is mainly on practicality than perfect security. So practical security as against perfect security. So we need two pieces of information, and they should go in the routing table of a router. So everyone knows that the router actually has a forwarding information base that it uses to look up the destination. Yeah? So the routers actually have a table. Every time a packet comes in, they look up the prefix, the longest prefix match in that packet, and they map into that table that they have, and that table tells them what outgoing interface the packet should go in. So this is a result of your routing protocols. Your routing protocols run, then you get a forwarding information base, which is what I'll refer to as FIB throughout. And that table tells you how to route it to a destination. We need to enhance that table. And now that table should contain these two pieces of information. One is that prefix. So the router has one table and it looks up the destination prefix and forwards the packet. Now a new packet comes in and you first want to do a spoofing check. You look at the packet source address and you look at your router, look at your prefix, the corresponding prefix in your fib. And that prefix tells you what is the marking that this packet should have come with if the network that originated it was deploying it. Yeah? So let me try to draw this. So there is, I can just write here, right? So this is your fib. And this is your prefix as of now. And this is your interface. That's all a router needs now, right now. So it can say 1.2.3, this class C address actually needs to go out on interface 2. That's your basic routing table. Are you able to see it or no? Because I can see it all over. So this is the key point. If we don't get to evaluation, it's not a big deal. I want to make sure that the key point is clear. Where is it?
This little CD's got it. It's got it.
Okay. So you have a prefix, you have an interface, and at this point, a router just looks at the destination address in a packet, says what interface it should go in, and it just sends it out, and that's all it does today. However, what I'm saying is you incorporate deployment status as a bit, saying it's deploying or it's not deploying. And let's say this is a deploying prefix, and you do a marking. So the marking could be letters A, B, C, D, for example. And that's the new information that's contained in your routing table now. So a packet comes in, it has two IP addresses in it. It has the source IP address and it has the destination IP address. It looks at the source IP address and it says, let's say the source IP address is here. And it says, for this source IP address, I'm not concerned with the interface because this isn't the destination IP address. This is just the source IP address. I say, okay, what's the marking for the source IP address? If the marking contained in the packet is the same as stored in the table, I say, okay, it seems like this packet contains the correct marking, right? Then I say, now I can actually forward this packet wherever it needs to go. Then I say, what is the destination IP address? Let's say this is the destination IP address somewhere else in your table. I do need the interface information because this packet is actually a genuine packet and I want to send it out. However, to decide whether or not to put the marking, I need to look up whether the deployment status is 1 or not for this destination IP address. Yeah.
Do you mean that you have to have a marking for each and every address in the network?
I will come to that point later. Yes. Yes.
That's not very scalable for a network of the size of the internet, for example.
Okay, so
And you have
if
to have it on every single router in the network. So
yes.
But it only needs its neighbors.
No, actually that's not true. It needs to, the prefixes are unique. So what it needs to know is while going towards destination, at least one router will be encountered. So as long as I know the existence of one deploying router, I'm fine. However, this information needs to be kept for every prefix. So that's a very good question. Think about a core router, a router that sits in the backbone of the internet. A core router typically has of the order of 200,000 entries in it, which is enough to route in the entire internet, right? So a core router already has information about every possible prefix in the network. Some might be aggregated, but that doesn't matter, right? For a core router, keeping this extra information, one happens to be just a bit, and the second happens to be, let's say, a 64-bit pattern, is not a big deal. However, for edge